Hey y'all, this is Mrs. Tran-bloom. We are now in Unit 4. Just to remind you guys that Unit 4, we will not have an exam for this unit, but all of its content will be on your final exam, okay? So let's start with 2.6. So this one, it's sort of a little bit of each chapter. So we have one section from 2.6, we have one section from 3.4, and 3 sections from 11 and just one more from 12.1. Now 2.6 and 3.4 are all applications. So you guys make sure you guys pay attention, careful attention to each example, all right? Example A string of 12 inches long is to be cut into 2 pieces. So you have 12 inches long. It's to be cut into 2 pieces, and we don't know where we're cutting, okay? One piece will be shaped as a square, so we are going to draw a square. A square means every single side is exactly the same, and the other will be shaped as a circle. And again, we don't know how or where we're cutting the string. Example 1A, express the total area, is now called A, enclosed by the pieces of string as a function of length x of a side of the square. So every single variable, make sure you understand what it is assigned to. So each x is a side of the square. So as you can see right now, this perimeter is now 4 x's, right? Because perimeter is adding up the side. So currently, we're using 4 x's for the perimeter. So that means the perimeter of the circle, well, in circle, we don't really call it a perimeter, we call it a circumference, right? The circumference of the circle is 2 pi r, but we have already used 4x for the square. We have 12 inches total, okay? We have used 4x already for the square. So we take it away from 12 to give us the perimeter of the circle. Okay, remember, we were given 12 inches to begin with. So now it says, okay, write an area of both shapes. So area of both equals the area of the circle plus area of the square, and it wants it in terms of x. So area in terms of x would be area of the square first. Let's do the square is x times x, which is x squared. Area of a circle is pi r squared, but it does not want r in it. Remember, we want it only in terms of x, and x means one side of the square. So we have to get rid of this r and then chuck in only variables of x. Well, I do have an equation with x and r over here. So what we're going to do is solve for r, okay? So let's do it. We're going to solve for r by dividing each and every term by 2 pi. Just like that. So that will give us r equals 12 divided by 2. That's going to be 6 over pi. So this is 6 over pi. 4x divided by 2, that will give us 2x over pi. Now you can also write r equals 6 minus 2x over pi, which is what I'm going to use. So back to your area formula. We are going to put in 6 minus 2x over pi, and it's r squared, so it's now square plus x squared. So now as you can see, I'm going to try to reduce this a little bit, okay, because you have pi on top and bottom. So this is a pi here. This is 6 minus 2x quantity square. I'm also going to write pi square. Remember, when you have a quantity square, you can break it up into 2 squares, just like top and bottom. So this will allow me to cancel 1 pi on the top and 1 pi on the bottom. So your final area of both shapes in terms of x. And remember, do you know what x represent? I hope you do, because if you don't, you're going to be in trouble because you don't know what you're looking for if you don't know what each variable represents, right? X represents one side of the square. A represents what? The total area of both shapes. So now we have the formula to find the total area of both shapes. B, what is the domain of A? Okay, so now it wants to know the domain of A. Well, what on earth is A? What A are they talking about? Ah, they're talking about this A. Okay, remember, anytime that you are reading a question, make sure you know what each variable represents. So it said, okay, well, you have an equation. Now tell me what the domain is. Well, would you guys agree? The domain means what input, what X has to be. Okay, I hope you do. Now, if X represents one length of the square, would you agree? Okay, would you agree if X represents one length of square, would you agree it has to be then bigger than 0? Because you can't make a square that's a negative length, and you can't make a square if it's a 0 length, so it has to be bigger than 0. Now, what is the biggest length? What is the biggest length of X? What is the biggest value of X? Okay, then now we got to go back to your string. If you have a string of 12 inches long and do you have a square, that means each, remember, this is 4 X's, right? So you divide into 4. So the most this could be would be 3. Now, it can't be exactly 3. That's why I'm not using less than or equal to. It can only be 2.99999, right? Up to 3. Then whatever's left over could be used for the circle. So what if you have 2.999 like this, right, as X? Well, that means you still have a little bit left for the circle. Yes, that's a very small amount of string to make the entire circle. And so normally we can't do it by hand, but that does not mean it's not doable, right? Any small amount that's left, it's still feasible to make a circle. But sometimes we can't just do it by hand. That's why we use machine to do a lot of stuff. So the domain of A, and remember, A is the area of both shapes. The domain is looking for the values of what X could be, what the input could be. So X, since this one says it's one side of the square, it has to be positive numbers only. And because you have a string of a total 12 inches, then that means there's 4 sides. So the most that it could be is up to 3, but not including 3 because we still need to leave a little bit left for the circle. C, graph A equals A of X. And again, what on earth is A equals A of X? Okay, so make sure we know, okay, well, that means this equation. So now I'm going to use decimal for this particular example and graph it out. So I'm going to bring up my decimals and enter in your A of X equation, okay? Just like what we have on our paper. So A of X equals 6, as you can see, take away 2x, the quantity of that square, all, and then divided by pi, then plus x squared, the bottom. So now that we have this, as you can see, I have a parabola, okay? Now this parabola, as you can see here, I'm going to go and flip my computer really quick and label the x and y axis for you. So your x-axis is one side of the square. Now the y-axis is total area for both shapes. So you have to understand what each variable represents for whenever you guys are doing an application. And it's looking for the smallest side, right? So all we do is we're going to go in and trace that value. So currently the smallest side that you can have, which again is the x, right? 1.68. So go back and write 1.68. x equals 1.68, and I think the original unit would be inches. Okay. When the area for both shapes to be smallest. Now on the exam, I might also ask you what is the smallest combined area. Then you could also add that on. So this is an addition here, okay? The smallest combined area is, let's go back to decimal and look for the y, 5.041 is 5.041 inches square, since it's an area. Now, just a little recommendation here, guys. Don't be stuck on just the circle or the square. I may add in a triangle. I may add in a rectangle. I may add in whatever shape I want. So try to understand the concept and the steps more than be stuck on the shape. All right?
Example 2. Let P equals x comma y be a point on the graph of y equals x squared minus 1. So whenever you guys are working on a problem, make sure you guys understand each and every variable. Right here it says P is x comma y is a point on the graph of a parabola. So the first thing you might want to do is do a sketch of your curve. It's a parabola because it's an x squared. And you have the vertex at 0, negative 1. I do need at least 3 points to make any curve, 2 points to make a line. Because it's a parabola, I need 2 more points. So I'm going to plug in x equals to 1. 1 squared is 1, minus 1 is 0. So when x is 1, y is 0. I know it is symmetrical, so all I'm going to do is go to the other side and do a little sketch. So y equals x squared minus 1. That's a curve for our parabola. Example A, express the distance d from P to the origin. Well, origin is right here in the center, which has an order pair of 0, 0. Remember, they defined the P earlier. P is your point, and now it's giving you another variable called distance, which is d. So let's just say, okay, well, where on earth is P? P could be here, P could be here, or here, or here, or here. P could be any unknown point on the curve. So what it's asking us to do is find this distance, okay? If that's right there, or this distance, or this distance, or that distance. Any point on the curve to the origin. Since we don't know exactly what the point is, we will find the distance in terms of an equation. Distance formula, students, is always x1 minus x2 quantity square plus y1 minus y2 quantity squared. Well, we know one of the points is the origin. It says from any P to the origin. So from here, we would go, okay, well, the origin, let's call it 0, 0. We're going to subtract. And P is this right here. So 0 minus x quantity squared plus, again, I'm going to let the origin be x1, y1. So 0 minus, and y2 would be my P, which is y quantity squared. So simplify that out. It's just now x squared plus y squared. Well, but students, it says only in terms of x. That means the input for this distance formula may only be x and only x. Well, the first one's fine, but this is not x right here. So we have to get rid of it and put in only in terms of x. So whatever y is, I have to find out what y is and plug it in. Well, in the question itself, it says y is x squared minus 1. So guess what? I gotta plug it in just like that. Whenever I see y, I substitute it with whatever it gave me earlier. So we can leave it like that, students, or you can simplify. So on the test, I'll be fine having this as an equation. And if you want to sit here and distribute out the x squared minus 1 in the combined like term, that's also okay. I'll do that for you as well. So here we go. We will have x squared. We are going to FOIL out the middle x squared minus 1, so that would be x to the 4th. In the middle, you would have negative 2x squared and then a positive 1. So after combining like terms, you would have x to the 4th minus x squared plus 1. This will also be acceptable. Again, you don't have to FOIL. Oops, I forgot to write the 1. You don't have to FOIL, but if you do FOIL, that's what you would get. Now let's go on to part B. Part B says, what is D? Remember, D is the distance from any point to the origin if x equals to 0. Then from here, students, we just have to use either formula that you have above, the d of x equals square root of x squared plus the quantity of x squared minus 1 square, or the one that you distributed, whichever is easiest for you. I'm just going to use the first one. Okay, when x is 0, that's 0 square plus quantity 0 square minus 1 square. So as you can see, it comes out to be 1. So the distance, I'm sorry, you should plug in 0 here. The d of 0 equals 1 unit. Okay, so what does this mean? It means the distance from the origin, I'm sorry, distance to the origin, correction, when, let me just delete all of these dots here, so that way I can have a better picture. So what this is saying is, when x is 0, okay, x is 0, students, it's this dot right here. Because that dot is, if I were to label it, is 0, negative 1. When x is 0, the distance to the origin is 1 unit. So that is, go back to the graph, and it's absolutely true. Algebraically and graphically, they should always match. C, what is the distance to the origin if x equals to 1? And again, you can plug in to the first equation or the one that you distributed. It doesn't really matter. Let's go and do the one that you distributed, just in case that you did do that. Okay, so when x is 1, again, I just go and plug in 1 here, d of 1. So 1 to the 4th minus 1 squared plus 1. This will give us 1 unit. Okay, so let's go and check with the graph to see if that's actually true. When x is 1, which is right here, okay, this is going to be 1, 0. So that's when x is 1 to the origin. Again, that's 1 unit. So far, we're doing fine. Now, letter D. What is the distance to the origin when x equals rad 2 over 2? Let's plug it in. And again, you get to choose which one you plug it in. Okay, so d of radical 2 over 2. Let's plug it into the original. So this is slowly plug that in, square minus 1 quantity square again. Okay, so d of rad 2 over 2, students, is under the radical, rad 2 over 2 quantity square is now 2 over 4, and then plus all of this is square here. So I can reduce that to 1/2 minus 1. Let's do some basic math over here. d of radical 2 over 2 equals radical. This is 1/2. And 1/2 minus 1 quantity square, as you know already, 1/2 minus 1 is negative 1/2, just like that square. And that will give us 1/2 here, and then plus 1/4. So d of rad 2 over 2 equals square root of 3/4. Yes, you do have to rationalize this. So that's radical 3 over 2. So the distance from when x is radical 2 over 2 is rad 3 over 2. So rad 3 over 2, so if let's pick a point, okay? As you know already, radical 2 over 2 is less than 1. So this is what it's saying. If I pick a point when x is less than 1, which let's say, okay, so let's say this is your dot of radical 2 over 2. What is that distance right there? So that distance should be radical 3 over 2. Now students, radical 3 divided by 2, it's about 8.7. I'm sorry, not 8, I'm sorry, 0.87. Radical 2 divided by 2, it's about 0.71. So that distance right there is less than 1 unit long, okay? And we are going to verify that in a little bit with decimals. Using a graphing calculator to graph a function d equals g of x. So when you're doing this on your homework, on your test, what does that even mean? Well, d earlier says the distance from any point to the origin. And then it said, okay, go and write the distance in terms of x. We have those, okay? Those are d of x right there. You can even graph that one or that one. It doesn't matter. And this one has restriction, students. Only when x is bigger than or equal to 0. Round it to 2 decimal places. Find the values of x at which d has a local minimum. And in parentheses, giving us what it means to be a local minimum. This gives the point on the graph of the parabola y equals x squared minus 1 closest to the origin. Okay, so let's go and find our decimals. And we are going to graph out your d of x, which, let's find that. Okay, let me see if I can make sure it's over here. Let me enter that in. Oh, sorry, I'm trying to flip my computer so I can type it. Okay, so let's type in the equation. And that is y equals, so d of x equals square root x to the 4th. I'm using the distributed one. It doesn't matter which one you use, guys. It really doesn't, okay? Plus 1. Okay, so let me move it over here so you can see it. I typed it in. Okay, so as you can see right here, this is the distance formula. So what I mean by that is x, let me label the x-axis, okay? X is distance to origin. And then, I'm sorry, x is not, y is distance to origin. Y is distance to origin. X is going to be just x. X is x. There's nothing, okay. And, okay, so it's not a parabola. So I want to be, actually, you know what? Let's graph out the parabola as well so you can see what I mean. Oops, x squared minus 1. So we have the parabola and we have the distance formula. I'm going to show you the difference between them both, make it a little bit darker so we can see. So earlier we talked about where is rad 2 over 2. So rad 2 over 2, students, is about 0.71. So if I go down to 0.71, okay, right there, okay? So here's 0.71 and we talked about, okay, well, what's that distance to the origin? So let's go do the same thing. Let's plot the point. Radical 2, let me type in radical 2 divided by 2, comma, let's see. Actually, let's do this. Sorry, I'm gonna graph out another graph. X equals radical 2 divided by 2. Okay, so here's where the rad 2 over 2 intersects. Can you see this? So this right here, it's rad 2 over 2. Let's look at what the distance is. The red is the distance formula. So the distance is 0.866, which is rad 3 over 2. So you can see that's the distance. Okay, so what if we go, okay, when x equals 0. Okay, when x equals to 0, on the blue, remember the blue is the parabola, and we looked at it earlier. Okay, so from this blue curve to this origin, that should be 1 unit long. But we can also just go straight up to the distance formula, which is in red, and see that the y value, remember y value represents distance to origin, is 1 when x is 0. We can also do x equals, nope, not z, x equals 1. Okay, so x equals 1, this is the blue one, is the parabola to the origin. So if you can see that distance is 1, but we can go straight up to the distance equation, which is in red, and we know the y is 1. So as you can see, when x is 1, the distance is 1. So now your question E says, using a graphing calculator to graph the function. We did that, which I would need you guys to sketch it out. Whenever you, for this one is asking you guys to use a calculator, then you can use decimal or your calculator as long as you sketch it out, okay? Find the values of x in which d is a minimum. So let's go back to decimal. Whoops. Okay, so d is a minimum, which I'm going to unhighlight these things, so we don't need these for now. D is a minimum when x is bigger than 0. So I'm going to restrict this. X is bigger than or equal to 0. Okay, so that means I only have half of this, okay? So there is the lowest point of the curve, okay? So the lowest point of the curve is 0.866 when x is 0.707. Let's go and write that down and sketch that out. So use a graphing calculator, so just go ahead and sketch this out. And it looks like it only wants positive side. Okay. And then just kind of dip down a little bit here and then goes back up. So here is the lowest point. So find the values, okay? The point closest to the origin is 0.707, 0.707, comma, and I think that was 0.866. 0.866, okay, but it says rounded 2 decimal places, so let's cross that out and write 0.71 comma 0.87 and box that up. Okay, now I want to add something, students. In the case that on the test or your homework and I don't limit I don't restrict it to x equals to positive values only, then as you can see, there are 2 minimum points, okay? So there's this one and this one. So just be very careful. If there's no restriction on x, you should have 2 answers that will give you the same exact shortest distance to the origin, okay? So, but this one, it restricted the x. Normally I don't, so make sure if I don't restrict the x, you know that there should be 2 answers.